Okie dokie, so now this is for part 2. We're going to be going through a couple more topics which are very, very likely to come up. And so this will be hopefully very, very beneficial for you guys. Okay, the first thing, this first question, it's on binomial expansion. So we're going to do 2 different types of binomial expansion questions. And go through them and see how we can best solve them. Now, remember that there are 2 formulas. There is the 1 plus x to the power of n, and then there's the a plus or x plus y to the power of n, where you do n choose r and so on. So for this question, we would use the n choose r for it, and we would just go straight to find the 5th and the 3rd of 3 minus a half x to the power of 6. So the trick here is that for all natural numbers you would need to use, so for all natural numbers you would use the n choose r and the x plus y to the power of n, and any rational numbers like negatives or fractional powers, you would do you would use the other 1 plus x to the power of n. Okay, so the reason we want the 5th, okay, so we want the x to the 5 term for this. Okay, so it's going to be 6 choose 5 times 3 to the power of 1 times minus a half x to the power of 5, and that's going to give us minus 9 over 16 x to the power of 5. Okay, so we've got the 5th, but remember, because we have to times that out by the 5, we also need to find the 3rd x to the power of 3, so that we can times it out by 8x squared and get get x to the power of 5 basically. So to get x to the power of 3, we would do 6 choose 3 times 3 to the power of 3 times minus a half x cubed, okay, which is minus 135 over 2 x cubed. Okay, and so to find the total coefficient, we're going to times this one by this 5 here. So we're going to do 5 times by minus 9 over 16 x to the power of 5, and we're going to add it on to 8x squared times by minus 135 over 2 x cubed, and that is going to give us in total, that will be minus 45 over 16 x to the power of 5, and that will be minus 540 x to the power of 5, and so the total answer will be minus 8,685 over 16. So that is going to be your answer for this question. Okay, now for this one, it's another binomial expansion, but if we rewrite 4 minus 9x and we write it to the power of a half, we now know this is a fractional power, and so we need to use the 1 plus nx, so on. Okay, so we need to use our second type of expansion for this one. So that is like very, very key here, being able to spot when to use which binomial expansion formula. So here we're going to use the 1 plus x to the power of n, because the nth power is a rational, so it's a negative or fractional basically. And then it's going to be 1 plus nx n minus 1, 2 factorial plus n minus 1, n minus 2 over 3 factorial x squared, this is x cubed, and that's 4 terms. So let's use it now, but before we use it, we need to factorize it out. So that's going to be 4 to the power of a half and 1 minus 9 over 4x to the power of a half. Okay, so that's going to give us 2, and then 1 minus 9x over 4 to the power of a half. So that's going to give us 2, 1 plus a half minus 9 over 4x over 1 factorial plus a half minus 1 minus 9 over 4x squared over 2 factorial, and like so on and so forth. So the next one will be minus a half minus 1 minus a half minus 2 minus 9 over 4x cubed over 3 factorial, and then when we expand it, and you get 1, and then 1 minus 9 over 8x minus 81x squared over 128 minus 729 x cubed over 1024. Okay, and then you just expand it out with the 2, so you get 2 minus 9 over 4x minus 81 over 64x squared minus 729 over 512x x cubed. Okay, that's your final answer. And now it says the student uses this expansion with x is equal to a 9th to find an approximation for root 3. Use your answer to part A, and without doing any calculations, state whether it will be an overestimate or an underestimate. Now we've only worked out 4 terms for this, but if we were to work out x to the power of 4, x to the power of 5, we'd get more accurate to root 3's approximation. Okay, so because it's all negatives, if I went on with this, the negatives would make it smaller. And so this particular answer is an overestimate. So try and really understand this, because it's all negative. If we kept going on, we'd get our value to be smaller and smaller and smaller. And so it's a overestimate. Okay, now with arithmetic sequences and series, you can get very basic questions, but this one's slightly different, and that's why I chose it, because they're likely to give you something slightly different in your exam. Okay, so first it says that you got A1 is 3 and the next is 8 minus A1. So show that this sequence is periodic. Periodic means that it fluctuates like up and down, and so it's going to be the first A1, it's 3, A2, it's going to be 8 minus 3, A3 is that, so that's 5, A3 is going to be 8 minus 5, so it's going to be 3 again, A4 is going to be 8 minus 3, so it's going to be 5 again, so it's periodic because of this. There you go, that's for that mark, and then the order is just 2 because it's going up or down in 2. Okay, so the order equals 2. You want to find the value of the sum from n to 85 for this sequence. Now, you are not going to use your arithmetic or geometric series as you usually would, because it's a periodic one. So this one, you have to think about it a bit manually. So because it's periodic, you know it's just going to be 3, 5, 3, 5, so on and so forth. Okay? And so you know that it's, because it starts with 3, because there's 85 in total, you're going to have 43 3's in this from 1 to 85. So that gives you 129, and then you're going to have 42 5's, so that's 210. And then you can just add this and you'll get 339 as your total for this. So not hard, but a bit different to what you guys are used to. Now this one is another quite difficult one. So it says show that 3 over 4 to the power of n cos 180n is 9 over 28 between 2 and infinity. So for this, the first thing we need to do is we need to realize that this is cos 180, and the graph for cos 180, it's minus 1. And so we're going to replace this by minus 1 to the power of n. And then we can just sub in 2 to get our first term. So when we sub in 2 here, we get 9 over 16. So our a is 9 over 16. And remember that our sum to infinity formula, that is a over 1 minus r. So it's 9 over 16, 1 minus r. So r, if we find out the second term, we can do the second divided by the first. And so we'll get r is minus 3 over 4. And so r is minus 3 over 4. And when you put that into your calculator, the sum of infinity is equal to 9 over 28. And that's your answer. Okay. Next one is a lovely proof by contradiction, also proof by exhaustion. So proof by exhaustion, it's basically just a proof where you sum all the, you exhaust all the different possibilities that you can have. Okay, so here it says use proof by exhaustion to show that for n is all natural numbers, so 1 to infinity, and n is less than or equal to 4, that n plus 1 to the power of 3 is greater than 3 to the power of n. So what we could do is we can put in 1 to 3 in, because 1 to 3 is it satisfies both of these conditions, and we can show. So if I put 1 in, I'll get 2 cubed is greater than 3, which is 8 is greater than 3. So that shows it. Then I can put n equals 2 in, do the exact same thing. So 3 cubed is greater than 3 squared, because 27 is greater than 9. Put in 3 as well. And put in 4 actually as well, because it's less than or equal to. Okay, so you guys get the gist, but that's all for the 2 marks. Given that m cubed is plus 1 is odd, use proof by contradiction to show using algebra that m is even. Okay, so for proof by contradictions, you always have to do assumptions. So here we're going to assume that there exists an m which is odd, making sure that m cubed plus 5 is even. So an m which is odd, you have to write what I've just said, by the way, but I'm not writing it, where k is basically an integer, such that m cubed plus 5 is odd. So if we expand this to k plus 1 cubed plus 5, expand and simplify, you can also use binomial expansion to do it as well. Plus 6k plus 1 plus 5. Then you will get 2 bracket 4k cubed plus 6k squared plus 3k plus 3, which is actually even. So that goes against the assumption that that would be odd. So that's a contradiction. So you do have to lay these out very, very detailed, not like I have, but you get the idea. Okay, this is a tricky one in the sense that you apply quite a few different things for this question. So for this actual question, I am going to, I don't know if I can write in the corner here. Okay, no, I can't. I have got the space on the other slide, but let's have a go. So express 2 cos theta minus sine theta in the form r cos theta plus alpha. So this one's not too difficult. Let's try it. So 2 cos theta minus sine theta in that form. Let's do it here. So you have 2 cos theta minus sine theta. Where is this fat pen? And I want to put it in r cos form. So we know that if we write it out in r cos theta plus alpha, if we expand this addition using addition formulae, so it's r cos theta cos alpha minus r sine theta sine alpha, and so r is going to be, we could just do 2 squared plus minus 1 squared rooted. That gives you root 5. And then for cos theta, we know that the 2 is equal to the r cos theta. Sorry, r cos alpha. So cos alpha, it's 2 over r. And sine theta, that is 1 is equal to r sine alpha. So sine alpha is equal to 1 over r. Okay? And then 1 over r plus 2 over r is just a half. So tan of theta is a half, which is 0.464. Okay? That's your answer for the first part. Now for the second part, where t is the time after, so the point at the end of the paddles is shown. The water level is assumed to be horizontal and at constant height. Using the model, find the max height. So the max height occurs when this part is equal to 1, because the cos curve's highest point is 1. So we can literally just set 0.5 plus 0.6 for what we just got in this. We could just set that equal. So first of all, let's write it out what we got for the first part. So for the first part, we got root 5 cos theta plus 0.464. And here it's 0.5 theta or 0.5 t. So if we just set that, that the max of it is 1, then we can find our answer to this. So our max, the answer would just be 3 plus 2 root 5. So that's our answer for part B, part 1 of part B. And then we can set 0.5 plus 0.5t plus 0.464 equal to 0 and 2 pi, where the two maximums occur, and our t would be 11.6. Now I'm just doing this really fast because we don't have much space to write it all down. Okay? And then the next part is when the wheel goes under the water when h equals 0. So what we could do is we just make the 3 plus 2 root 5 cos 0.5t plus 0.64 equal to 0. So our two values for t here are going to be 3.684 and 7.026, and then we can find the difference between them. So if we set 3 plus 2 root 5 cos 0.5t plus 0.464 equal to 0, we can get the two values. Then for the value of capital T, it's going to be the difference between them. It's going to be 3.34. Okay, and in reality it says the water level may not be of constant height. So obviously the 3 would have to change for this. So that would be the last bit. Okie dokie. So this is a trig identities question. You're very likely to get a trig identities question with double angle formula. So let's start working through this. So first, we know that cot 2a can be written as 1 over tan 2a. So we're just going to write that as 1 over tan 2a times by tan a. And then we can expand out what tan 2a is. So tan 2a, it is 2 tan a, 1 minus tan squared a. And so we're going to rewrite that as 2 minus 2. 2 minus 2 brackets, and we want to flip that because you want 1 over, so 1 minus tan squared a goes at the top, tan, or 2 tan a goes at the bottom, times tan a. So that and that cancel, that and that cancel, and you're just left with 2 minus 1 minus tan squared a. 1 plus tan squared a, and that is sec squared a. So this one was quite a simple one, but that's your answer. Okay, so this is the last question, numerical methods, Newton-Raphson. It says the equation is 2x cubed plus x squared minus 1 equals 0, and it has exactly one real root. So show that for this, the Newton-Raphson formula can be written as follows. Okay? So what we are going to do here is first we are going to find use the Newton-Raphson formula. So we know that it's x minus f of x over f dash of x. And then we know that f dash of x, so f dash of x, that is 12x, we want f dash of x for 2x cubed plus x squared minus 1. So it's 6x squared minus 2x. So that's going to give us x minus 2x cubed plus x squared minus 1 over 6x squared minus 2x. Then I need to times it by xn. So when I do that, I need to make a common denominator. So xn times 6x squared minus 2x minus 2x cubed plus x squared minus 1 all over 6x squared minus 2x. Okay? And I also need to times this side by xn as well. So that's my common denominator. Then when I expand it, I will get 6x cubed n plus 2x squared n plus 2x cubed n minus x squared n plus 1, which is 4x cubed n plus x squared n plus 1 over whatever this is, so 6x squared n plus 2xn. So that is what you are asked to show. Okay? And for the next bit, use the formula with x1 is equal to 1 and then find x2 and x3. So this is really easy. You just sub 1 into here and then the answer to that into here. So you should, for x2, you should get, when you sub it in, you should get 3 over 4. And for x3, when you sub it in, you should get 2 over 3. Okay, and lastly, it says explain why for this question, the Newton-Raphson method cannot be used with x1 equals 0. So here, we know that it cannot be used because it is at a turning point. And when it's at a turning point, f dash is 0, so this part of the formula wouldn't work. Okay, so that's why it can't be used. Now that's the end. Altogether from part 1 and part 2, it's out of 76 marks. So give yourself a mark, and in the description you can download the paper and try it a few times until you feel really, really confident, until you feel like you can get all of the marks. You know, all of the topics here are labeled as well. So you've got circles, you've got another circles one, vectors. This is another vectors one, but with like cos and sine rule. And you've got your polynomial division and factor theorem, binomial, both ways. For binomial, then your arithmetic or periodic series sequences, geometric, proof by contradiction, trig modeling, trig identities, and then this one that we just did as well, so Newton-Raphson. So, you know, go through everything, try it, and let me know how you guys get on in the comments. And also, this is my new channel and it's something that I want to do just to benefit you guys. So if you can like and subscribe, then hopefully it can reach more people as well. So thank you guys. See you.